All right, double displacement reactions. This time, everybody gets a partner. Okay, so these are a little bit different in that these are a compound plus a compound. These primarily happen in aqueous solutions. So usually you have an aqueous solution of two different compounds. You mix them together, you get a reaction. They are different from single displacement because single displacement is an element plus a compound. This is a compound plus a compound. And once again, the general parts are replacing their corresponding parts. Okay. Instead of having an activity series, we need to have one of three things happen in order for a double displacement reaction to occur. Okay. It can form water. Okay, so it forms something other than an aqueous solution. Okay, that's what all three of these are. So if it can form something other than an aqueous solution, the reaction will occur. So this one forms water because the H and the OH go together, the Na and the Cl go together, they switch partners. So the H and the Na switch places, and HOH is H2O, water. Okay, formation of a gas. I won't do these you won't see these in the workbook because you don't know enough to know when a gas forms. But this is what happens this is vinegar, and this is baking soda. So you mix those two together, you're going to get the Na and the H are going to trade places. And that H2CO3 that you get breaks up into water and carbon dioxide gas. And then finally, the formation of a precipitate. We talked about those when we talked about state symbols. That's the formation of a solid. Okay. So once again, the way a double displacement reaction works is the two metals is usually the way I like to think about it. They trade places. Okay. So the magnesium goes with the bromine or bromide, and the barium goes with the sulfate. Okay, and you get this, and then we can check to see if a precipitate forms. Now, the question is, how do we know whether or not a precipitate has been formed? Okay, we can use solubility rules or a solubility table to help determine this. Because basically a precipitate is when something is not soluble or insoluble. And so solubility rules, to me, once again, that's like an AP or a college chem level topic. I'm not worrying about that. You have a solubility table in your workbook, and we're going to use that to figure it out. So with single displacement, we were able to figure out if the reaction occurred first, and then we could figure out the products. Well, double displacement is kind of the other way around. We have to figure out the products first. Then we check the solubility to see if the reaction occurred. So here's a copy of your solubility table. Okay, so if it says AQ, it stays in aqueous solution, nothing happens. But if it says PPT, that means it's insoluble and it forms a precipitate. All right. So let's look at some examples. Okay, magnesium chloride and sodium carbonate. Magnesium and sodium are going to switch places. All right, so I'm going to get the sodium's going to come over here with the chlorine. Magnesium's going to go over with the carbonate. All right, and so I get those two. You go back to your solubility table and the way you read this. So let me go back real quick and show you how to read the solubility table. So our first product is sodium chloride. So I come down this side where the metals are, okay, and I get down to sodium. And then I go over to sodium chloride. Notice sodium's always soluble, by the way. And I get AQ, so it's soluble. Okay, my other product was magnesium carbonate. So I go up to magnesium, and I go over to the carbonate column, and where they intersect, it tells me, oh, it's a precipitate. So back over here, so it says AQ and PPT, this reaction occurs. Okay. You then need to go back and balance it. Well, it is balanced, so I put a 2 there to balance it. All right, we repeat the same process with potassium iodide and silver nitrate. Potassium and silver trade places. So the silver goes with the iodine, the potassium goes with the nitrate. Once again, you go back to the solubility table, track silver over, find the iodide column, and you will find that it is a precipitate. And you will find that potassium nitrate is aqueous, always soluble. And then you will see that accordingly. Okay, so the reaction occurs. But if I do these two together, sodium's always soluble, potassium's always soluble. They're both aqueous, so if both of them come out aqueous, if neither one of them is a precipitate, There's no reaction. When we do these, so just practicing, when you write them out, so you predict the product, I'm just going to show you this one real quick. You always need to put this on the end. Or whichever one's the precipitate. You need to tell me which one is the precipitate. Okay, don't just simply write the product and say the reaction occurs. You actually need to identify which one becomes the precipitate. Okay, otherwise it's not fully complete. Okay, so you got to do that. So a lot of books would have AQ, AQ, AQ written after these because they're all aqueous. That's how these reactions occur. All right, so let's look at the next one. Zinc and potassium switch places. Potassium goes with the chlorine. Zinc goes with the hydroxide. Check your solubility table. Looking at the solubility table, the potassium chloride I know is soluble, and then zinc hydroxide is the precipitate. Okay, just looking at that solubility table. So that's a precipitate. Identify it, then balance if needed. Okay, next one, sodium nitrate and copper 2 sulfate. So copper 2, when they switch places, copper 2 is going to go with the nitrate, which is soluble. Sodium is going to go with the sulfate, which is soluble. There's no reaction because there's no precipitate. So draw a line through your products and write no reaction, just like I did there. Okay, same thing down here. Ammonium is going to go with the bromine. Silver is going to come over and go with the chlorine. Check your solubility table. And silver chloride is the precipitate. Okay, notice the precipitate can be the first one or the second one. It's not always the last one. Okay. And then same thing, switch them, check them. There's no reaction there. Okay, so that is double displacement reactions. Similar to single, but just a little more time consuming to do because you got to do the products, then check their solubilities in order to tell whether or not the reaction occurs. And so that's double displacement reactions.